All right, ladies and gentlemen, yesterday we learned about graphing parabolas that had the a value of 1. We know that the a value tells you how wide or how narrow it is. So here's the parent graph that we looked at yesterday from our notes. It's a regular U-shaped curve, the parabola. It's a parent graph f of x equals x squared. And we know that the a value is 1, so any other parabola that has the a value of 1 is going to be exactly as wide as this one. It's going to be the same exact U-shape curve. It's not going to be wider, it's not going to be narrower. The a value determines if it's wide, if it's narrow, and also if it opens up or down. If it's negative, it opens down. Anyways, because we know that the a value 1 will produce this exact width of a parabola, we could use the coordinates of the parent graph, 1, 1, 2, 4, 3, 9, as a pattern, right? So that was a review from yesterday. But right here, it says, what if your a value is not 1? Well, then you can use these steps to graph this with an input-output table. However, I don't recommend doing this. It does take a while. I would actually recommend jumping straight into modifying your a value, okay? Some teachers say, oh, well, if your a value is not 1, you can't use the pattern 1, 1, 2, 4, 3, 9. I say that if your a value is not 1, you could still use the coordinate or the pattern 1, 1, 2, 4, 3, 9, but you have to modify the outputs of your pattern by whatever your new a value is, okay? So right here I specifically say that your a value is 2. If we look up here, this a value is 2. So we know it becomes narrower. So let's go back down here, and you have to modify your outputs by the a value of 2. So it's kind of like this, guys. Here are our outputs, and if I take my a value of 2, this is my a value, and I multiply it by my outputs, I will get my new output, okay? So if I say 1 times 2, well, I will get 2. If I say 4 times 2, I will get 8. If I say 9 times 2, I will get 18. So ladies and gentlemen, my new pattern, my new modified pattern is 1, 2 instead of 1, 1. It's 2, 8 instead of 2, 4. And it's 3, 18 instead of 3, 9. Again, we're still using the pattern 1, 1, 2, 4, 3, 9. We're just modifying the outputs by multiplying the outputs by whatever a value is, whatever your new a value is. Because that's what the a value does. It either makes it wider or narrower, or using the correct math vocab would be, it makes it a vertical stretch or vertical compression or stretch. And in order to do that, it modifies your outputs. Just multiply your a value by whatever your output is. So here's your modified pattern. And I guess it's important to say modified pattern for the a value of 2. So instead of 1, 1, it's 1, 2. Instead of 2, 4, it's 2, 8. Instead of 3, 9, it's 3, 18. Okay. So instead of going with my original intent of showing you how to graph by ignoring H and K and then making an input-output table, plugging in numbers, pulling out answers, which does take a long while, let's go with our new modified pattern, okay? And how are we going to do this? How are you going to do this on the quiz? Well, write down the pattern that you know, 1, 1, 2, 4, 3, 9. Now remember, these guys are your inputs, these guys are your outputs. So we need to modify the outputs by your new a value, which happens to be 2. So take the outputs and go times 2, times 2, times 2, and you will have the new modified pattern. Let me write it down here, or over here on the side. 1, 2, 2, 8, and 3, 18. You're not even going to use 3, 18. So how do we graph this? Well, let's start with H and K. Okay, H is negative 4, so go negative 1, 2, 3, 4, and then go down to negative 6, negative 1, 2, 3, 4, 5, 6, and you'll end up right here. Let me put that in red. And after we draw our vertex, or graph our vertex, which is negative 4, negative 6, second step would be to do the axis of symmetry, which is that dotted line going right through the vertex. And we know that the axis of symmetry equation is always x equals, because a vertical line is always going to be x equals a number, and it happens to be the x value of your vertex, which is negative 4. And this will be, I believe, one question on the test Friday, so make sure you understand how to write that axis of symmetry equation. Super easy. It's like a free point. And then after that, we need some coordinates. Okay, now normally we would go with 1, 1, 2, 4, 3, 9, but the a value is 2, so we have our modified pattern 1, 2, 2, 8, 3, 18. So let's go from the vertex 1, 2. Let's do that. Put a dot right there. And then go 2, 8. So from the vertex 1, 2, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8 right there. And if I did go back to the vertex and go 3, 1, 2, 3, 18, I'm going to be off the graph. I'm not going to do that. I'm just going to use those two. I want to map them over to the other side using this beautiful axis of symmetry, whoops, that we just dotted in right there in green. And now we're just going to draw our parabola. And we are done. So once again, we graphed this intricate parabola that has an a value other than 1 with h's and k's, and we just by understanding how the a affects the width or the narrowness, as you can see, this is a little bit more narrow than our original parent graph. Let me show you the parent graph. It's slightly more narrow. If we compare, see that? Slightly more narrow. Okay, I got kind of confusing. Sorry about that. But anyways, the a value did make it a little more narrow, and the h and k shifted it from the origin over here, 4 to the left and 6 down. All right, so the fact is, you could still apply the pattern 1, 1, 2, 4, 3, 9. You know what, by the way, since we didn't use these steps, let's just scratch them out. But don't get me wrong, I mean, you could always treat it like a function machine, and you could make an input-output table right here, an XY table, and you could plug in 0. Imagine that, plugging in 0. 0 plus 1 is 1. 1 squared is 1. 1 times 1/4 is 1/4. And then 1/4 plus 1 is 1 1/4. So when you plug in 0, you get out a 1 1/4. That would be the coordinate 0 and 1 1/4 of the way up. That'd be let me zoom in a little. 1 1/4 would be 0, and 1 1/4 would be right there. So obviously that would take a lot of work and a lot of opportunities to make mistakes. So let's use the pattern. The pattern's pretty straightforward. What's your original pattern that you know? The original pattern is 1, 1, 2, 4, 3, 9. And what are you going to do? You're going to modify the outputs, which are these guys. You're going to modify these guys by your new a value, which happens to be 1/4 in this case. So multiply the 1 times 1/4, multiply the 4 times 1/4, multiply the 9 times 1/4. Okay? And of course, you could use a calculator if you'd like. So what's your new pattern? Well, 1 times 1/4 is 1/4, or you could write it as 0.25, right? 1/4 of the way, or 0.25. Let's move on to the next one. 4 times 1/4, that one's easy. That's going to be a nice, beautiful 1. Okay, and then the last one, 9 times 1/4. Well, remember, put the 9 over 1, then multiply the top with the top and the bottom with the bottom, and you will get 9/4. Okay, now 9/4, that might not mean too much to you right now, but change it to a decimal. If you take a calculator and you go 9 divided by 4, that'll be 2.25. Okay, 2.25. Anyway, what is our pattern? It's 1, 0.25, not even halfway up, right? It's 2, and then 1 up, and then 3 to the side, and 2.25 up. So let's first identify our vertex. As a matter of fact, I'm kind of doing step 2 before step 1. Step 1 is to identify your vertex. That's -1 for h. Think opposite of what you see. Take k for what it is, which is 1. So let's go to -1, 1, put a dot right there. Let's draw our axis of symmetry. So once we get some coordinates right here, we'll be able to reflect it over to the other side of that axis of symmetry. Might as well state the axis of symmetry equation, which is x equals the x value of your vertex, which happens to be -1. And now let's use the pattern. Again, the new pattern is 1 to the side, 0.25 up. Now, why up? Because the a value is positive. So 1 to the side, 0.25, a quarter of the way up. It's not even halfway up. It's half of the half. It's right here. So it's going to be interesting drawing that. Okay, let's move on. Go back to the vertex, and now you're going to go 2 over and 1 up. So from the vertex 2 over and 1 up right here. Let's put a dot right there. Let's go back to the vertex, and we're going to go 3 over and 2.25 up. Okay, so 3 over, 1, 2, 3, and then 2.25 up. 1, 2, and a quarter of the way up. It's not even halfway, it's just right there, a quarter of the way up, 0.25 of the way up. So let's put a dot right there, quarter of the way up, not quite halfway. Now let's map these over to the other side. So this guy that was a quarter of the way up is 1 unit away. Go 1 unit this way, and it still has to be a quarter of the way up. Let's put that dot right there. The next one is up here, and the next one is up here, a quarter of the way up. Okay. Hopefully you guys see that. 1 unit away, 1 unit away. 2 units away, 2 units away. 1, 2, 3 units away. 1, 2, 3 units away. Okay. And that's our parabola. Let's just graph it. There it is. And if you're thinking, well, wow, that's a pretty wide parabola. Well, heck yeah, it is. Why is that? Because the a value is 1/4. And remember, when your a value is closer to 0, it's going to get wider. When your a value is further away from 0, it's going to get narrower, right? So when your a value is 1, yeah, you could stick with 1, 1, 2, 4, 3, 9. But if your a value is different, you have to modify the outputs, okay? These guys of your pattern, the outputs of your pattern, you have to modify them according to whatever this is. If this were a 3, you'd be saying 1 times 3, get 3. 4 times 3, get 12. 9 times 3, get 27. If this a value was, let's say, 1/2, then you'd say 1 times half, you get half. 4 times half, you get 2. 9 times half, you get 4.5. So the a value is what you multiply your output of your pattern in order to continue using your pattern. Right? Now, I know it seems a little complicated, but the more you practice, the easier it gets. And trust me, guys, it's way the heck easier than making an input-output table, right? I mean, you could use an input-output table, but this would take a really long time, and there's so many opportunities for mistakes, right? Imagine plugging in a -2 or a +2 right here, and then 2 plus 1 is 3, 3 squared is 9, and then 9 times 1/4 is 9/4, and then you have to add 1. Forget about it. Okay, it's way easier to just use the modified pattern if your a value is not 1. Again, what's the domain right here? You say x equals all real numbers. What's the range? Y is clearly above a certain value. At or above a certain value, which is +1. The axis of symmetry we already stated. I'm not going to ask for x and y intercepts on the test, but something that you should know anyway. So we've gone over that example. This one was slightly narrower. This one was definitely wider because of the a values being different. So what could you guys tell me about this one, even before graphing it? We already know that this is going to open down because it's negative. The a value, if it's negative, it opens down, which in the correct math vocabulary, we're going to say it's a reflection over the x-axis from the parent graph, right? Opens down. It's slightly narrower because it's further away from 0, and it has a vertex -3, +6. So let's start with that vertex. -3, +6. Let's go -1, 2, 3, up to 6, which is right here, I believe. Next step would be to draw that axis of symmetry right through that vertex. And then after that, we want to use the pattern. What is the pattern? It's 1, 1, 2, 4, 3, 9. But we need to modify the pattern because, again, this pattern is for the a value of 1, and this a value is 2. Now, some students say, wait a minute, the a value is -2. Yeah, you're right, the a value is -2. But I'm not going to worry about the negative sign. The negative sign just tells me that the parabola is going to open down, okay? So when I get my modified pattern, I'm not going to go 1 over 2 up. I'm going to go 1 over 2 down because I know it's negative. So you don't have to include this negative sign when you're talking about the pattern. But you do need to modify the pattern's outputs by that new a value. So again, let's modify it by the new a value of 2. So I'm going to multiply by 2, multiply by 2, multiply by 2, thus giving us a new pattern 1, 2, 2, 8, 3, 18, right? So 1, 2, 2, 8, 3, 18 is the new modified pattern when your a value is 2. Just remember that it opens down, so you're going to be traveling down instead of up because of the negative on the a. So let's go to the vertex and let's go 1 over 2 down. So if I go 1 over 2 down, I get to this point. If I go back to the vertex and go 2 over 1, 2, 8 down, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. I'll be right there. And of course, let's map these over to the other side right here and right there. And that's about it. There's my slightly narrower parabola because the a value is further away from 0. It is opening down. It's at the vertex -3, 6. What else could we say? The domain is always going to be x equals all real numbers. The range is always going to be y is either greater than or equal to or less than or equal to the y value of your vertex, right? So y is going to be less than or equal to the y value of your vertex. See, that's the maximum height on y. What's that maximum height? It's 6. So it's at 6 or below. Okay. Moving on. Number 2. So number 2 here, let's get our new modified pattern. So instead of, well, let's start with the vertex. Let's always start with the first part, the vertex. The vertex is a coordinate 0, 4. So 0, 4, it's right here. Axis of symmetry would be going right through it, which is the y-axis itself. Your old pattern, 1, 1, 2, 4, 3, 9, is going to get modified by the new a value of 1/2, right? Again, the negative, we could just ignore it because that just tells us that it opens down, that it got reflected over the x-axis. So we're going to say 1 times 1/2, 4 times 1/2, and 9 times 1/2. So your new pattern, let me jot it down right here. It's going to be 1, 1/2. It's going to be 2, and 4 times half is 2, so 2, 2. And then 3, and 9 times half is 4.5. Okay, so that means 4.5, right? So let's go 1, 1/2. So 1 over halfway down. Let's put a dot right there at halfway down. Let's do that in red. And then let's go back to the vertex and go 2 over 2 down. So 2 over 2 down, put a dot right there. Go back to the vertex and go 3 over 1, 2, 3, 4.5 down. So 1, 2, 3, 4.5 down. That's going to be right there. And then, of course, we're going to map over the coordinates to the other side of the axis of symmetry. So this one that's halfway, we're going to just map it 1 unit away this way to this halfway. Okay, right there. So here we go. And then the next one, it's 2 units away, 2 units away, a nice clean point right there. And the last one is down here at the halfway point. Again, it was halfway, so go 1, 2, 3, stay at the halfway point, 1, 2, 3. That's how you get there. There's our parabola. And yes, the domain is x equals all real numbers, and the range is y is less than or equal to the y value of our vertex, which happens to be 4. Oh yeah, and the axis of symmetry would be x equals 0. Moving on, number 3. Again, let's begin by doing step 1, which is stating the vertex. The vertex is going to be +1, -5. So if we go to +1, -5, right here, right on the edge, let's draw our axis of symmetry right through that vertex. And the axis of symmetry is the equation x equals the x value of your vertex, x equals h. That's just 1 right there. Axis of symmetry is x equals 1. And then, of course, we need coordinates, so we're going to use the pattern 1, 1, 2, 4, 3, 9, but we need to modify that pattern by the new a value of 2. And I should have said modified the pattern's outputs. We're going to modify it by 2. So we're going to multiply the outputs times 2. So times 2 times 2 times 2. So instead of 1, 1, you're going to have 1, 2. Instead of 2, 4, you're going to have 2, 8. Instead of 3, 9, you're going to have 3, 18. And you're probably not going to use that last one. Maybe not even the second one. Let's see what happens. So from this vertex, we know it opens up because it's positive. So you're going to use 1, 2. So go 1 over, 2 up. Let's put a dot right there. I should do that in red. Let's go back to the vertex and go 2 over and 8 up, right? So we have 5, 6, 7, 8 right there. And of course, let's map these over, because if I went 3 over 18 up, 3 over 18 up, it's going to be way off the graph. It's totally pointless. So just map over those coordinates to the other side, which would be right here and right here. Again, 1 unit away, 2 units away. And now let's just draw our parabola right through those points. Okay. Again, the domain, x equals all real numbers. And the range, y, is going to be either greater than or less than or equal to In this case, y is greater than or equal to the y value of your vertex, which happens to be -5. So at this point, I believe, I don't want to make this video any longer than what it is, but I think you already get the hang of it. You need to modify the outputs of your pattern 112439, and I believe you should be able to do these 4. The answers are on the back. It's graphed. All the details are there, so you can check your work as you go.